Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important topic, that is the statistical mechanics according to your advanced syllabus of the CSIR statistical mechanics. What is the first topic is first order phase transition. The second topic is second order phase transition. The third one is diamagnetism. The fourth one is paramagnetism. The fifth one is the ferromagnetism. After ferromagnetism, the subsequent topic of the ferromagnetism is Ising model. How the questions are coming through the Ising model, we have to discuss in this video once you able to see. So, in December 2018, they are asking this question in CSIR examination for 5 marks. Any question will come in CSIR examination based on the Ising model, that is the 5 marks question only. Clear? Please try to understand. The Hamiltonian of a one-dimensional Ising model, the Hamiltonian of a one-dimensional Ising model, Ising in 1925 given one model, such model we call it as a one-dimensional Ising model. Of the n spins, n is large, he has to take. First you have to consider here n is the large. Which value you have to take? N value is the large. Whatever the data they are giving, that data you have to write it is. That interaction energy H is equal to minus J into summation I is equal to 1 to n sigma I plus 1, sigma I plus 1, where the spins sigma I is equal to plus or minus 1 they are giving. So, your beta is equal to the reciprocal of the temperature 1 by kb into T, that is the what they are asking, the correlation function between the nearest neighboring spins. What is the correlation function between the nearest neighboring spins they are asking. So, based on this problem, we have to discuss about the correlation function between the nearest neighboring spins. How we able to calculate the correlation function between the nearest neighboring spins? We have to follow this procedure. How we have to follow this procedure once you able to see. So, this is very important to try to solve this problem. First we have to take the, we have to take the nearest correlation function between the nearest neighboring spins, sigma I into sigma I plus 1, which is equal to what we have to write it is summation of sigma I into summation of sigma I plus 1 is divided by n minus 1. This is the formula. If n is a large value, if you have to take it as a from the data, n is the large value, n is equal to large value. So, therefore, you have to neglect this one. So, you able to write it as a sigma I into sigma I plus 1, which is equal to summation of sigma I and to sigma I plus 1. So, but you have to take, let you are going to discuss as a sigma j I plus 1, you are going to take it as a, that is minus 1 by j you have to take, is divided by 1 you are going to diminishes. So, n is there. So, you have to write it is sigma I plus 1 is equal to 1 by minus j you have to take, where j is the coupling strength between the two neighboring sides. So, but you know that the sigma I is equal to plus or minus 1. So, therefore, what we have to write it is 1 by minus n into j. So, you have to write it as a, so sigma summation of sigma I plus or minus 1, you have to take it as a, for 1 you are going to take it as a up. So, down you are going to take it as a, the second nearest particle you are going to take it as a down. So, this one you are going to write it as a average energy of that particle. So, because that is the according to our Hamiltonian, that is our average energy. So, therefore, what we have to write it is which is equal to that average energy is divided by minus nj. This is the equation number 1 you are going to write it is, which is equal to, that is the correlation interaction sigma I dot sigma I plus 1 is equal to. Clear? So, now you able to take, what we have to write it is, we know that partition function for a corresponding to the n plus 1. If n is a large number, the partition function is equal to cos h beta j whole to the power of n if n is large. So, what you have to take if it is n is large, your partition function is equal to this one. So, therefore, you have to write it as a ln z n is equal to what we are going to write it is n into ln cos h beta j you are going to write it is this is the partition function. Now, we need to calculate the average energy is equal to minus dou by dou beta of ln z. Already this formulas we know that minus dou by dou beta of ln z is equal to n ln cos h beta j, n ln cos h beta j, n minus n you have to take outside. So, dou by dou beta 1 by, so x that is the cos h beta j, again you have to differentiate cos h beta j, sin h beta j you are going to get it, again you have to differentiate, so j you are going to get it. So, therefore, what you are going to take your average energy value is equal to you are going to get it as a minus n j sin h beta j is divided by cos h beta j is equal to tan h beta j. This is the equation number 2. So, now equation number 2 you have to substitute in equation number 1. Equation number 2 you able to substitute in equation number 1. So, what is your equation number 1? The interaction, the correlation interaction of the spin of the adjacent particles. So, sigma I dot sigma I plus 1 is equal to, that is the average energy is divided by minus n j is there. So, therefore, average energy is equal to minus n j into tan h beta j is divided by minus n j. So, minus into minus n j get cancelled. So, therefore, the correlation interaction function sigma I into sigma I plus 1 which is equal to what you are going to get it as a tan h beta j. This is your answer. So, therefore, you have to check in your answer. So, what is answers list you able to see. So, e to the power of minus beta h is not correct, you have to take, this is not correct. So, minus is not correct. Which option is correct? Tan h beta j, option C is correct, cot h also not correct. Like this you have to do in your competitive exam. So, very simple. This is the Ising model. Who discovered this Ising model? In 1925, Ising is discovered this Ising model. Ising model, in one dimensional Ising model, randomly oriented, so it won't exhibit the ferromagnetism substances. So, it is approximately equal to the paramagnetic substances like that. So, already I am informing you, we started the CSIR and GATE online coaching center. So, online platform we started. So, that is our app. This is Quantum Online Academy app. This is my number 9908437460. So, you can contact me. First, you have to download my app through your app through your Play Store. You have to download it. After downloading, you are able to see the courses like this. This is the foremost and first course we started. That one only we are teaching now right now from 1 year onwards. CSIR and GATE physics course and JL and DL physics course is there. Whatever the classes I am teaching in the CSIR, those classes only I am uploading. So, I am not keeping particular for the JL and DL. So, whether it may be according to the syllabus, I am uploading the videos in this. You have to take this course is very useful to you. So, all information I am teaching that one. So, if you want to get the individual paper also available, mathematical methods of physics, classical mechanics, electromagnetic theory, quantum mechanics and statistical physics. Now, we are almost in the end of the statistical mechanics, clear. So, please share and subscribe and like our YouTube channel. Like these videos I will give you, so in our YouTube channel. So, not only that, you have to try to purchase our app, you will really crack the exam. Thank you so much.